Uh, Hello, my name is Yuno Shin from Polymer Physics and Application Lab. I will start presenting my own research field. My own research field is solid electrolytes for lithium secondary batteries. The use of fossil fuels has caused the high temperature of the Earth, and among greenhouse gases, carbon dioxide is the main cause of global warming. Carbon dioxide is most often generated when fossil fuels such as oil and coal are burned. Thermal power plants, steel mills, cement plants, and oil are widely used in domestic heating and automobile operations, generating a large amount of carbon dioxide. Therefore, energy storage systems have rapidly been developing as environmental pollution, such as global warming, is getting worse due to the large use of fossil fuels worldwide. Among them, lithium secondary batteries are used in various fields because they are the lightest weight, long cycle life, and they meet environmental regulations, and it can be divided by purpose. First, there are saturated markets such as electronic devices, smartphones, laptops, and tablets. Second, there are growing markets such as cars, buses, electric bicycles, and portable energy storage systems. First of all, a lithium-ion battery is composed of four components: cathode, anode, electrolyte, and separator. Regarding the charging and discharging principle of lithium-ion batteries, when charging, the lithium ions and electrons are stored toward the anode. Lithium ions move to the anode through the electrolyte, and electrons move to the anode through the current. Conversely, when the battery is discharged, the lithium ions and electrons in the anode move to the cathode. When all the lithium ions and electrons move to the cathode, the device turns off. In lithium-ion batteries, electrolyte system is one of the important components because it strongly impacts on performance of battery capacity, cycling stability. These conventional lithium secondary battery are lightweight and use liquid electrolyte, so it has good fluidity. Thus, it can get high ionic conductivity and have high energy efficiency because their energy density is 3 times higher than other batteries. However, due to the use of liquid electrolyte, which are compostable materials, thermal stability of a lithium secondary battery is poor because there is a risk of explosion or fire due to electrolyte decomposition. This results in a low energy density and a low battery life. Therefore, a lot of research is being conducted to create a system that replaces existing organic liquid electrolyte with solid electrolyte. Therefore, when used as a non-flammable solid electrolyte, it is safe for leakage and volume expansion against external impact. And solid electrolyte does not use a separator, so it has a high energy density. However, solid-state batteries have the disadvantage of having a high potential distance between solid electrodes and electrolytes and a lower ionic conductivity than liquid electrolytes. And also it is uh, difficult to get high ionic conductivity and high mechanical strength at the same time. Uh, Next, as for the classification of solid electrolyte, solid electrolytes can be classified into three main categories: solid polymer electrolytes, inorganic solid electrolytes, and composite solid electrolytes. First, the solid polymer electrolyte consists of polyethylene oxide, polypropylene oxide, polypropylene carbonate polymer, including a polar functional group and lithium salt. Second, inorganic solid electrolytes can be classified into sulfide solid electrolytes, such as LGPS, and oxide solid electrolytes, such as silicon, acetone perovskite, and garnet. Finally, there are composite solid electrolytes, in which organic polymer solid electrolytes and inorganic solid electrolytes are combined. And there are many types of polymer-based electrolytes. First of all, as for the characteristic of polymer solid electrolytes, the ionic transport mechanism in polymer solid electrolytes depend on dielectric constant of the host polymer, ion pairing, ion sizes, amorphous characteristic, and the polymer containing the polar functional group can accommodate the lithium ion and form polymer salt complexes. And also, if there are many amorphous regions, polymer electrolyte can get good ionic conductivity. And low molecular weight polymers exhibit low TG. Finally, speaking of the advantage and disadvantage of solid polymer electrolytes, the advantages of solid polymer electrolytes are excellent chemical stability, easy electrode interface formation, and easy processing. In addition to PO-based solid polymer electrolytes, as for three solid polymer electrolytes, polycarbonate-based solid polymer electrolytes can get higher ionic conductivity and better electrochemical stability than polyester-based solid polymer electrolytes. Polyester-based solid polymer electrolytes with low glass transition temperatures and high dielectric constant have been applied as polymer hosts. It can also be used as major components of blends or block copolymers. And it features high electrochemical stability against oxidation. And for the polysiloxane-based solid polymer electrolyte, it can have very low glass transition temperature, so it can have high ionic conductivity, but it can have poor mechanical strength. Therefore, to mitigate the poor mechanical strength, it can be used by cross-linking or embedding into the polymer network. Compared to solid polymer electrolytes, gel polymer electrolytes possess higher ionic conductivity at room temperature. In gel polymer electrolytes, there are lithium salt, polymer, and organic solvent. The liquid electrolyte is immobilized in a polymeric matrix and could be reduced the risk of leakage compared to commercial separator. Gel polymer electrolytes combine the advantages of both the liquid and solid components. As for the pros and cons, it can have good thermal and chemical stability, good electrochemical stability window, and high ionic conductivity. However, it has relatively low mechanical durability, so nanomaterials should be introduced into gel polymer electrolytes. And As for the inorganic solid electrolytes, include sulfide-based solid electrolytes and oxide-based solid electrolytes. As for the sulfide-based solid electrolytes, have good thermal stability and ionic conductivity, and also have good mechanical strength and flexibility. As for the disadvantages, it is sensitive to moisture, so hydrogen sulfide gas can be generated and may eventually cause battery performance problems. In addition, there are disadvantages such as narrow electrochemical stability window and high cost of germanium. And as for the oxide-based solid electrolytes, have the advantages of high thermal stability, high ionic conductivity, and a wide electrochemical potential window. However, as a disadvantage, it is difficult to make large capacity batteries, and it has high temperature sintering process. And finally, as for the composite solid electrolyte, to solve this, as for the composite solid electrolytes, are being developed that minimize the disadvantages of solid electrolytes while gaining the advantage of each organic material and inorganic material. As for the advantages, composite solid electrolytes have high ionic conductivity, good mechanical properties, wide electrochemical potential window, high thermal stability, and highest chemical stability. However, there are disadvantages such as low interfacial contact and high cost